The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content. You can earn continuing education credits through ACI's online CEU program. Visit www.concrete.org to register. ACI conventions provide an opportunity for networking and for keeping up to date with the latest in concrete technology and practices.
The next presentation is by Niels Nielsen. He's represents a manager and owner of Convi APS in Denmark. He's a mechanical engineer by background and has worked with the Danish Technical Institute for Steel Fiber Reinforced SCC in evaluating the means to optimize a better system. He's a past member of Rheology committees on SCC concrete. He's going to talk right now about the Viscoprobe, with which his company has been instrumental in developing and building and evolving. And I think you're going to find this to be a very interesting presentation to further enhance what we need for SCC. So without further ado, Niels.
Yes, good morning. Yes, I'm going to take you a little bit further into controlling the SCC production. And to this, I will introduce you to the Viscoprobe. The outlines of my speech will be a small introduction and then something about the Viscoprobe and a study we made about the Viscoprobe compared to a real rheometer, and then some quality control issues. As we have heard from the Neil and Max, the SCC is sensitive to almost all changes in the materials going into the production process. And there is a need to control the rheology, to control the production of SCC. As the Viscoprobe is a system to measure the rheological behavior directly in the mixer, this will be the tool to help there. Rheology in SCC is mostly about the Bingham model. And for this reason I'll introduce the Bingham model. I think it is known to most of you, but shortly. We have a velocity force diagram here. And to start a movement, a shear movement in concrete, in SCC concrete, takes a certain force. This force, named B, is the yield stress. Increasing the shear velocity increases the force. That means we are increasing the shear velocity, we get a higher force. The increase of the force related to velocity is linear. For this reason, the straight line. The incline of this line is the plastic viscosity of the fluid in this situation of the concrete. And to put this into an equation, says the force equals A multiplied velocity plus B. The A value is the incline of the line, and the line we normally call the viscosity line for the liquids. The A value and the B value in this equation provides all information about the concrete flowability. And then the Viscoprobe. The Viscoprobe system has a measuring probe, and this measuring probe are built into the mixer. In planetary mixer there are one probe, and in turbine mixers there are two probes. The probes are fixed to the actuators in the mixers, to the mixer star in the planetary mixer, and to the arm system in the turbine mixer. The probe is measuring the shear force needed to force this ball through the concrete, and the shear force is measured by a load cell placed in this area of the probe. From the turbine mixer, from the two probes here, we get out two shear force curves, the upper curve from the outer probe and the lower curve from the inner probe, due to the difference in velocity of the two probes. In the planetary mixer, we have only one probe moving in a planetary movement. Moving in a planetary movement gives sinus-formed velocity variation, and this sinus-formed velocity variation gives out a sinus-formed force curve, a sinus-formed shear force curve from the probe. By taking the maximum value from this sinus-formed curve and the minimum value, we get the shear force at two different speeds, and we can use this to put into the force velocity diagram, and in this way draw the viscosity line for the concrete. Here you see when the level of shear force goes down and the amplitude goes down, we get a lower level, a lower shear stress value, and we get a lower incline of the line, a lower viscosity of the concrete. The measured values are radio transmitted from the probe in the mixer to an outside receiver, and the outside receiver is cabled to a PC, having an interface showing the rheological behavior of the concrete. The upper left diagram is showing the maximum shear force and the minimum shear force. From the planetary mixer, you can imagine the sinus-formed curve between these two lines. Over here we have the viscosity line, the velocity, max velocity, the minimum velocity, and the shear force put up, and draw the line. The lower left diagram is showing the plastic viscosity and the shear force. As I said, the two values telling all about the flowability of the concrete, and then the black cross, the actual state of the concrete in the mixer. So we know already when the concrete is in the mixer and mixed homogeneous, we know what the rheological properties are for the concrete. The study we made at the Danish Technological Institute was to study the Viscoprobe response for a full production with the fundamental values of yield stress and plastic viscosity measured by the 4C rheometer. The 4C rheometer is shown here. It is based on the good old slump cone an automatic system to lift the cone, and then a camera to record, to film and record the flow of the concrete when the cone is lifted. And this flow pattern is then monitored here, and comparing this curve to some mathematical made curves, they are able to take out the physical value of viscosity and yield value for the sample. The test was made at a Danish concrete production company in the CRH group, and the company is making prefab, pre-stressed concrete elements of various kinds. The test was carried out in a Horab 3,000 liter mixer with a Viscoprobe. In this situation, we only monitor the values from the Viscoprobe. The Viscoprobe is not connected to the control system. The concrete was mixed and was transported to an immediate hopper, and from this hopper it is discharged into a crane bucket. From the crane bucket, the sample was taken in a wheelbar and wheeled back to the lab where the test was made on the 4C rheometer. And after this, it was cast in the mold. One example of the result for mix design number 50. We have here the blue spots is the 4C rheometer values, and the green yellow are from the Viscoprobe. And they are, as you can see, pretty close to each other. That's leads to a conclusion, or first two facts. There were made 21 batches of SCC, and it included 5 different mix designs. And the conclusion from the Danish Technological Institute was that a reasonable correlation was obtained on the plastic viscosity and yield stress, both within the same mix design and between the mix designs. Quality control issues. I think that Max was telling the most of what I have been trying to say here. It takes a well-equipped and a well-run plant to make SCC concrete. But it also takes skilled people to make the right mix designs and make the right day-to-day decisions or batch-to-batch decisions. To make the QC work on the incoming materials, to make sure that the changes are within the accepted limits, to make robust and cost-efficient mix designs, defining the right flow properties of the SCC to get a good filling of the mold and to get a good surface of the casted elements, and defining the best pattern of filling the mold. That's also an issue. From the Viscoprobe, we get a picture like this when we are monitoring the mixing or the homogenizing of the concrete. We see the materials going into the mixer, the water and ash mixture bringing down the shear force, and after that we get a nearly horizontal and straight line, or 2 lines to be exact. If the mixer can't cope with the job, we get a picture like this, for instance, where we can see that the max shear force value never stabilizes, and the mixer discharge happens before the mix is homogeneous. This is another one where it looks as if it is nearly getting homogeneous here, but then the force goes up, and at the discharge time we get a big force on the Viscoprobe. That means that there was some unmixed, more or less dry concrete in the mixer when we discharged. More quality issues. The Viscoprobe is measuring in the full batch. That means there is no discussion about if the sample taken to measure the rheological values are representable for the full batch. It is simply the full batch giving the values. And it is, the Viscoprobe is measuring in all batches. That means there is no discussion which batch are we going to take a sample from to check. We get measurement from all batches, and we get the measurements without use of manpower. The measurements are taken when all materials are in the mixer. That means all small variations in the ingoing materials, small variation fines in the sand and concentration of admixture and things like that are taken into consideration when the measurement is made by the Viscoprobe. And the Viscoprobe is measuring rheological values for plastic viscosity and yield stress. And it makes it possible to make correction to the batch before the batch is leaving the mixer, so that the rheological parameters can be brought to the right value before the mix leaves the mixer. Yes, I'm now going to show you mix made in a Danish company. You will see now the curve is coming here. The materials are going into the mixer. And you see the viscosity line. The viscosity line doesn't have any meaning before the mix is getting homogeneous, so it is just moving around like. But this was the dry material goes into the mixer, and in a little while start adding the water, and the shear force increases in the beginning, and then the admixture, the superplasticizer goes in, and you'll see that the shear force is going down. When the shear force is stabilizing, we have here the viscosity value and the shear force value. When these two values stabilizes in a short while, we take our measurement by the Viscoprobe to make the adjustment and calculate how much water is needed to bring the concrete to the right rheological values. And then before the concrete is discharged, we control that the mix is within the target area. Normally we use the viscosity to calculate the needed water to bring it into the target area, and normally we only adjust with water because this is what is possible on practical plants today. But other things are possible to adjust with admixture or powders also. This is just a slide showing the values that was measured and how much water was added, and this is all in the documentation from the batch control system, so that afterwards people can go back and see what happened on this batch and what was the end values. Robustness of mix designs. big efforts are made to make robust SCC concrete, and often a high content of powder, fines and chemicals are used to cover over the lack of control during the mixing process. With the Viscoprobe, each batch can be controlled to be in the center of the robustness window, and in this way the robustness window can be made smaller, and it is possible to make more cost-efficient mix designs. You can see this target area for the Viscoprobe as a sort of robustness window. If you make sure that this square is within the shape of the robustness window, you are sure that if you hit the target area, you have a robust concrete. Also, the surface quality of the casted elements is sensible to the casting pattern. So if you define and control the casting pattern, and you control and document rheological values, flow properties for each batch, if you have these quality issues under control, it leads to better looking products and lower cost to surface repair. That leads to, by having we have the quality control department, we have the concrete production, and we have the casting area, then the quality control department makes the mix designs and decide the flow properties and give this information to the production. They produce the concrete with the right rheological values and deliver the concrete to the casting area. And then if people at the casting area doesn't agree completely, then they discuss with the Department of Quality. And if they think that it's necessary to make changes, they discuss with the production about it. This is a normal way of acting in a lot of industries. Today, the most normal way of acting in the concrete industry is that the conversation is going here. They call back from the casting area that they want to have more water in the concrete. The man at the mixer adds a little more water to the concrete, and a little later they tell him they want a little less water in the concrete. This way they act as quality management, all the people in the casting area. With the Viscoprobe, it is possible to measure the values in production, and then there's something to discuss with the quality department about. The Viscoprobe doesn't give all answers to production of high quality SCC, but it's a huge step in the right direction. Thank you for your attention.